Everyone, welcome to Standard 8 Physics class. In today's video lecture, we discuss about Chapter 8, which deals with electricity. In this chapter, we discuss about household consumption of electricity, safety components of household electricity, dangers of electricity, electric cells and batteries, and static electricity. Let us discuss one by one. First, we discuss about the different appliances, different household appliances of electricity, such as electric bulb, fan, TV, AC, which work on electricity or electrical energy. Different electrical appliances transform electrical energy into different form of energy. For example, an electric iron converts electrical energy into heat energy, while an electrical bulb transforms it to both heat and light energy. Electrical energy is actually the flow of charges through a conductor, which we commonly refer to as electricity or electric energy, electric current. Now discuss about electric power. The rate at which electrical energy is transferred is called electrical power. So P, mathematically P is equal to E by T, where P is the electric power in watt, E is the energy consumption in joule, and T is the time in second. The electrical power of some appliances is given in this table, so you learn these things. Now we discuss about electric meter. Electric energy consumed in houses is measured by electric meters fitted at the main boards in the house. This is the big figure of a electric meter. Electrical energy E is equal to electric power into time. We know that unit of energy is joule, but it is not used to measure electrical energy. This is because joule is a very small unit of energy. A large unit, the kilowatt hour, is used to measure electrical energy. So 1 kilowatt hour is equal to 1000 joule into 3600 seconds. So let's define 1 kilowatt hour. 1 kilowatt hour is the amount of electrical energy consumed by electrical appliances with a rating of 1 kilowatt in 1 hour. So 1 kilowatt hour is also known as 1 unit. The electric bills are calculated on the basis of the electrical energy used per unit or used in kilowatt hour. The readings are taken monthly and total electrical energy consumption is calculated. So how do you calculate? Total cost is equal to total electrical energy consumed in kilowatt hour into cost per unit. Calculation of consumption of electrical energy. For example, the cost of electricity is 6 rupees per unit. How much will a 2 kilowatt heater contribute to the monthly electricity bill of a house if it runs for 5 hours every day? Power consumed by the heater, P is equal to how much? 2 kilowatt hour, means 1 kilowatt hour is equal to 1000 watt. So 2 kilowatt is equal to 2000 watt. Total time it worked in a month, T is equal to 5 into 30, that is 150 hour. Five hours per day, so in a month 30 days, so 5 into 30, 150 hour. Energy consumed by the electric heater in 1 month, 2000 into 150, that is 3 lakh kilowatt hour, that is 300 kilowatt hour or 300 unit. The cost of running the heater is equal to 300 into 6, that is 1800 rupees. Electric supply in now we discuss about live, neutral, and earth wire. Electric supply in our homes is done through three wires. These are live wire, neutral wire, and earth wire. The live wire provides the path along which the electrical energy from the power station travel. This is brown or red in color. Remember, the color of live wire is brown or red. The neutral wire completes the circuit and provides a return path for the current. This is a black or blue in color. Color of neutral wire is either black or blue. The earth is usually has no current flowing through it. It is the that to protect you from an electric shock if an appliance develops a fault. This wire provides a safe, easy path for the electric charge to flow down to the earth and save us from an electric shock. This wire is green or yellow in color. Now discuss about safety components of household electricity. Electricity is important to all of us, but may be dangerous if we don't use it carefully. Therefore, we use some safety components of electricity. Some of these safety components used in electric circuit are electric fuse. This is the figure of electric fuse. An electric fuse is a short length of wire made of easily fusible metal. It is used as a safety device put into an electrical circuit to limit the current. Electrical fuse is made of a conductor of low melting point. When the current flowing through the fuse wire exceeds the prescribed limit, the heating effect of current causes the fuse wire to melt. This causes the circuit to break and thereby stopping the flow of current in the circuit. This is how fuse wire ensures our safety. The essential of fuse wires: it protects the electrical gadgets in use. It provides safety of building and persons. Fuse metals or blows that part of the electric circuit is also automatically disconnected when high current flows through the circuit. Thus damage to gadget or any fire that could have resulted from the overheating due to excess current is prevented. MCB. Nowadays, miniature circuit breaker insert, it is called MCB, are used with costly electrical appliances instead of fuses. MCB switches off the circuit in a very short time duration in case of any fault in the circuit. An MCB may be switched on again after repairing the circuit. Obviously, the use of MCB is far better than a fuse because MCB avoids the inconvenience of connecting a new fuse wire. Moreover, MCB is safer to use due to quick response. Grounding. Another safety measure is grounding. Safety appliances is grounding. Grounding is a safety measure used to help prevent electrical hazards. Let us understand this by considering the example of a refrigerator. A refrigerator is a metal box on rubber feet with electricity running in and out of it. The electricity going inside the refrigerator is isolated from the metal exterior. If for some reason the electricity comes in contact with the metal exterior, the rubber feet would prevent the electricity from going anywhere, but the electricity will remain inside the metal exterior. If someone would toss the metal exterior, the electricity would flow from the metal box of the refrigerator and can cause electric shock. Grounding is useful in such cases if in grounding a green wire is connected. A green wire is connected to the metal frame of the refrigerator. If metal box gets discharged for any reason, the unwanted electricity will travel through the wire back to your electrical panel. The green wire must be connected to something that is in turn connected to the earth or ground outside typically. This connection is grounded. Ground rod is inserted in the earth. In order to achieve good contact with the earth, a large metallic plate is buried under the depth of about 2 meters where the soil is most moist. The metallic plate is surrounded by a mixture of charcoal. This is the metallic plate which is surrounded by mixture of charcoal and salt. This helps in getting good contact with wet soil and hence the ground. Now discuss about dangers of electricity. Incident of our negligence may cause electric shocks and may have even lead to fire. So we need to be careful while using electricity. Using electrical appliances near water can cause explosion, fire or an electric shock. Overloaded socket can get one electrocuted or can cause fire. Opening of an appliances without unplugging it can get one electrocuted. Poking into sockets can result in an electric shock. We should follow certain safety precautions while working with electricity. Now we're going to discuss these safety measures. Never touch, try to repairing any electrical equipment or circuits with wet hands or when the appliance is plugged into a source of electricity. Never use equipment with thread cords, damaged insulations or broken plugs. Always use insulated tools while working. Always use appropriate insulated rubber gloves and shoes while working on any electrical circuit. Disconnect the power source before servicing or repairing electrical equipment. Never use an aluminum or steel ladder if you are working on any receptacle at a height. They may cause electrocution. Always use wooden ladders or ladders with insulation. Avoid contact with energized electrical circuits. Do not store highly flammable liquids in your electrical equipment. Now we are going to discuss about electrical cells and batteries. An electric cell is a small, simple device that provides electric current, which converts the electrical chemical energy stored in the cell to electrical energy. The AA and AAA cells, commonly known as pencil cells, that we use in TV remotes, chargers, clocks, etc., are examples of electric cells. They provide very small amount of electric current. They come in a variety of shapes and sizes. In all the electric cells, the electrical energy is generated as a result of chemical reaction between the chemicals filled in it. Every cell has two terminals. Every cell has two terminals, one is positive and another one is negative. When connected in an electric circuit, an electric cell derives the electron from one end to the other with the help of connecting wires. Now we are going to discuss about batteries. Sometimes we need to use more than one cell in an electric circuit to make electrical appliances work. Torch work with 2 or 3 cells. The combination of 2 or more cells is called battery. Battery can be categorized as primary and secondary. A primary battery is made up of primary cells. These types of batteries cannot be recharged once used. The secondary battery is made up of secondary cells and can be recharged easily. Secondary batteries are used as car batteries, inverter batteries, etc. How will you connect the electric cell to form a battery? The cells can be connected in many ways to work as a battery. Some of the ways are discussed below. Cells can be placed side by side so that the positive terminal of one cell touches the negative terminal of the other cell and so on. You see, this is the positive terminal of first cell, and this is the negative terminal. And positive terminal of second cell and negative terminal of first cell are in contact. So a torch works on a two cell joined back to back. Cells can be stacked up together to form a large battery. Positive terminal of one battery connected with the negative terminal of another. Similarly, positive terminal of second should be connected with the negative terminal of third, and so on. We can also use holder for two or more cells to connect together. This is all about the battery. Now we are going to discuss about static electricity, which is the most important chapter. You have studied static means rest. You have studied the electricity is generated due to the motion of electrical charges. However, there is another kind of electricity which does not flow, and it is known as a static electricity. In static electricity, a body develops charge that do not move. In static electricity, we will study about the electricity in which the charges do not move. Static electricity deals with the study of charges at rest. Charges are called static charges. Here charges means static charges. Charges are of two types. We know one is positive charge and another one is negative charge. And you also know that like charges repel each other and unlike charges attract each other. Now we discuss about conservation of charges. The charges present in a matter can neither be created nor be destroyed. These charges can only be transferred from one body to the other body. This is the statement of conservation of charges. For example, when you rub a balloon on your clothes, you are adding surplus of electron to the surface of the balloon. Rubbing of two neutral objects which have net charge as zero transfers electron from one object to another object. The object which loses electron acquires positive charge, while the object which gains electron acquires same amount of negative charge. If we add the charges of two bodies, the total net charge is zero. This is known as conservation of charge. It means that charge can neither be created nor be destroyed. Hence, principle of conservation of charge states that in an isolated system, the total charge is always constant, or charge can neither be created nor be destroyed. Now we are going to discuss about methods of transferring charges. The charges can be transferred from one body to another either by conduction or by induction. First of all, we discuss about the method of conduction, transferring of charges by conduction. A body can be charged by the process of conduction. If a charged object is tossed on an uncharged object, the electric charges flow from charged object to uncharged object. You see, this is a charged object and this is the uncharged object. This rod is negatively charged and the metal sphere is neutral. And when this method of charging a body is called charging by induction. By the method of conduction, the object attains the same charge as the charged body. This negatively charged body, when comes in contact with the neutral metal sphere, some negative charges transfers to metal sphere, and metal sphere also becomes negatively charged. Second method is the induction. Induction is another method of charging a body. In this method, a charged body is brought close to an uncharged body without touching it. The uncharged body is then grounded. The charged body then induces an opposite charge on the uncharged body. This method of inducing charge in a body is called induction. You see, this is the neutral metal and negatively charged rod. When the negatively charged rod is brought closer to the neutral metal body, the charges on rod is negative, so charges develop on neutral metal body is positive. And the metal body is grounded. Remember, which is very important. So now gold leaf electroscope. Electroscope is an instrument that helps us to detect whether an object is charged or not. Gold leaf electroscope is the most commonly used electroscope. Gold leaf electroscope is used to detect and measure charge on an object. A gold leaf construction of gold leaf electroscope. A gold leaf electroscope consists of a brass rod fitted in a glass jar through a rubber stopper. This is the rubber stopper. A brass disc is present at the top of the rod. This is the brass disc. The lower end of the brass rod that lies inside the jar has two thin rods. These are the two thin rods, lips hanging parallel to each other. Working, how does it work? Working of gold leaf electroscope. Take a glass rod and rub it with silk cloth so that it gets positively charged. Bring this positively charged rod near the brass disc of the electroscope and touch it. Next, touch the brass disc, your hand. Okay, what do you see? What do you observe? When you touch the glass rod rubbed with silk cloth to the brass disc, the gold leaves inside the electroscope diverge. When you touch the brass disc with your hand, the gold leaf collapse and come back to their original position. On touching the charged rod with the brass disc, the charge flows from the rod to the gold leaf. Since both the gold leaves carry the same charge, they repel or diverge. When you touch the brass disc with your hand, the gold leaf loses the charge to earth through your body. Due to this, the leaves collapse or come back to their original position. Now let us discuss about discovery of lightning. Most of us have observed the phenomenon of lightning during rainy season. In 1794, famous American scientist Benjamin Franklin demonstrated the electrical nature of lightning. He performed an experiment with a kite which he flew during the thunderstorm. The central spar of this kite was a 30 centimeter long iron wire. This iron spar was connected to a strong silk thread. This is the silk thread. The other end of which was connected to an iron key. When it started running, the silk thread became wet and allowed electricity to flow through from the cloud to the iron spar and through the wet silk thread into the key. Benjamin was lucky to not get electrocuted by lightning. Even today, the exact mechanism of lightning generation during a thunderstorm is not known. One thing that scientists are sure of is that thunder clouds carry electric charges and these charges separate out within the cloud. Lightning is a natural phenomenon based on the concept of static electricity. During the development of a thunderstorm, the huge masses of cloud gets electrically charged due to friction of clouds. with their air and also due to the presence of dust and carbon and other charged particles in the air. If one part of cloud has a negative charge, you see this part is negative charge, it can induce a positive charge on the neighboring clouds. That induces positive charge in the neighboring cloud. When two clouds are brought together by wind, the charges jump from one cloud to other through the air, resulting in the heating of the air, producing a bright glow of lightning. The sudden jump of electric charges through the air between two oppositely charged clouds is seen as an intense spark in the sky and is called lightning. A bright flash of lightning can also be visible between the clouds and the ground. The top of the clouds acquire excess of positive charge and the bottom of clouds acquire excess of negative charge. Simultaneously, oppositely charged particles are present in a large number on the Earth's surface. Due to the large number of opposite charges on either side, the attraction between the charges grows rapidly and these charges move toward each other with high speed. Due to heavy charge built up, the force of attraction is able to overcome air's resistance or insulation. As the static charge in a thunder cloud increases, the strength of the electric field around it increases. The charge from ground moves upward at a very high speed, which is visible as a bright flash of lightning. Thus, lightning is caused by the process of electric discharging in the form of bright light. The heat produced during the process of lightning heats up the air, which expands suddenly. This sudden expansion of air sends a disturbance in the form of vibration through the air, producing a loud sound which is called thunder. Now we are going to discuss about safety against lightning. High volt of spark can damage building. You know that lightning flash is highly dangerous and it carries a huge amount of electric charge. This high voltage spark can damage buildings, trees and anything on the earth. Many people die due to lightning strike, suffer from a variety of lasting symptoms such as memory loss, dizziness, weakness, numbness and other lifelong ailments. Thus we need to take safety precautions against lightning. So what kind of safety precautions should one take? Don't touch any conductor around. Stay indoors. If you are out of from home, seek shelter under a parking area, building or in a car. Don't stay in open areas. Never seek shelter under a tree because lightning can set a tree fire. If there is no place to take shelter and you are in an open field, sit down the ground with knees folded. Cover your ears with your hands. To minimize hearing loss, touch the heels of your feet together. This will give a smallest place a path to electric current if lightning strikes. Now the lightning conductor. Lightning conductor installed at the highest point of a building to protect the building from the damaging effects of lightning. Franklin was the first to suggest that a lightning conductor protects a building from lightning. The lightning conductor saves the building by providing a pathway for the charge to pass the ground. The lightning conductor helps in passing the charges to the earth. It consists of a metal rod, spikes at the top, and a copper plate attached at the lower end, which is buried in the earth. The cloud closes also loses its charge when it comes in contact with the lightning conductor. In this way, when lightning strikes the building, the charges flow to the earth. So this is all about the chapter, and with this your chapter is over, and your annual exam portion is also completed. So try to read in the proper way so that you can perform better in the annual examination. So thank you very much for watching this video.